Hello everyone, this is a new video for you. This video is about algorithms, and let me tell you that I in this moment it is 12 and 25, and I started recording this video at 8 o'clock in the morning. This I am recording and recording and recording because I had a lot of errors by explaining, and those videos were so long. So I'm gonna try in this one to do it a little bit faster and no longer for you, because I know that okay, for me there is not any problem if I am learning something. There is not any problem for me spending time for something that I want to learn. But I know that this kind of topics for you, maybe you are not interested, or maybe you are interested, but I know you, I know you. So let's start. I am not going to do this introduction too long. This video is about algorithms. Okay, so uh, here here, program development life cycle. So I'm going to try to explain this because across the PowerPoint presentation, the most slides you find here talk about this part, the program development lifecycle. Okay, so I'm going to try explaining step by step one of them to help you to understand all this. But let me here, I'm going to start moving. I'm going to put my mouse here and the keyboard here. Okay, and my iPad here because I need to show you, and I'm going to try to make better drawings than the previous videos that I record for you. But oh man. Okay. So the program development life cycle, PDLC. So as you are watching here, there are four stages here. Okay. So I'm going to start talking one by one. Okay. So let me here. I'm going to write now what is happening here. Something happens with my iPads. Okay. 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 So program development life cycle. Let's talk about the first one that is called analysis. Analysis. Okay. What is this, or what do you need here in analysis? Here you need to start identifying what do you need in the software that you are going to create. So remember, PDLC is a process of creating computer programs, and is composed of four stages. Okay, so the first stage is analysis, understanding the problem and its requirements. So I'm going to give you an example here. Let's talk about something here that possibly you know, that is the ATM process. Okay, do you know what is ATM process? The ATM process is a complete software that you find in the cajeros automáticos, Bancolombia, Servibanca, and wherever you find on the streets to do money transactions. Okay, so which are the purpose of ATM then? ATM is money transactions. Money transactions. Okay, so what do you need here? Obviously, here in money transactions, you need to know what is the transaction that you are going to do. For example, deposit money, withdraw money, uh, paying services, and more. But let's talk about just these three items. But let me bring something here because there is a lot of heat here. But let me Okie dokie. So let's continue. Okay. We are in the analysis stage here. Okay. So ATM is a huge program in which you are going to make money transactions. And the transactions that you are going to do is that you are going to put money inside your bank account. You are going to take money from your bank account, or possibly you are going to pay some services, for example, Claro, your water service, electricity service, and more. So what do you need here? You need to understand the information that is needed here. Okay? This is what you need to start doing in this part. You need to understand the problem and its requirements. Okay? I'm going to give you another example here. Okay, I'm going to try to doing it faster. Let's suppose that you are going to create a software. Let me put something here and I'm going to use another one. And let's suppose that you are going to create a software to calculate if a number, any number is even or an odd number. So what do you want to do? Okay, I want to calculate if any number is even or odd number. What do you need here? Numbers, okay? And what else do you need here? Um, Operations. What do you need in the first one? You need to know the number of your bank account. You need the amount of money and the transaction you are going to execute. Okay? Okie dokie. Let's continue here. So, when you are analyzing, you need to abstract information. So what that means? That you are going to understand what is the information needed in the software that you are going to develop. I'm going to talk about this one because it's easier than this one, but I am going to use this one to explain some examples here. Okay? So let's talk about a software to calculate if any number is even or odd. Okay, the first here is that you need to know the definition of even or an odd number. Okay, so maybe many people is going to tell you that even numbers are all the numbers that are multiples of 2, is all the numbers that are divisible by 2, or maybe another could say that the even numbers are all the numbers ends in 0, 2, 4, 6, 8. Okay, that's correct. But here you have information that are not necessary, because to create a software to calculate even numbers, you you cannot use this information, because there is no way. So you know it because you have the information, but remember that the computer doesn't have the information. The computer is not smart. You make the computer smart. Okay? So the computer doesn't know which are the multiples of 2. The computer doesn't know if any number ends in 0 or 2 or 4 or 6 or 8. Okay? So that is unnecessary information, but you can use this information, okay? Because you know that if you divide any number, let's suppose 4 divided by 2, obviously you are going to have a result, that the result is here. I'm going to put an X here. And here you are going to have something that is called the remainder. So the division by 2 is an useful information. So you're going to get this one and you are going to avoid all the information that is not necessary in your process. Okay? Okie dokie. Now, decomposition. That means that you are going to break down your problem into a smaller, more manageable parts. Okay? So, I'm going to give you an example. We are going to continue here, but let me, here, you are going to divide the even calculation number in two parts. The first one, you are going to calculate the remainder. Okay. And the other part that is according with the remainder, you are going to decide if the number is or not. Okay. So we are going to divide the huge program into ones. One is going just to calculate the remainder. In the other one, we are going to use the remainder to decide if the number is or not an even number. Okay. And obviously, you are going to have something that is called the requirement identification. So that means that if you want to do this, you need inputs. That means which is the number that we are going to calculate if is even or odd number. You are going to process the information. That means that here you are going to calculate if the number, the remainder. Then taking a decision, you are going to send an output. Okay? Okie dokie. So let's continue here. Now, we have, no, let's talk about this later. And let's talk about this later. Okay. As I told you that we are going to, let me check this one. We are going to take a program. Okay. And we are going to divide that program in sub-programs. Okay? And this is what I explained here. We are going to divide this process of calculating if a number is even or not. We are going to divide it in two. The first one is going to calculate the remainder, and the other one is going to decide if the number is or not even or odd number. Okay? So that is understanding computer system is made of subsystems. Okay, so a computer system is a collection of hardware and software components that work together to perform tasks. It can range from a simple calculator to a complex supercomputer. And now, what is a subsystem? A subsystem is a smaller self-contained part of a larger system. Each subsystem has a specific function and contributes to the overall operation on the computer system. Let me explain you here. Let's suppose you or your parents are this person that is going to go to a building, and that building is called the bank. Any bank, Bank Colombia or wherever bank you want to go to do some transactions. Let's suppose those are windows and let's suppose this is the door entry, okay? So when you go inside to your bank, you need to, okay, what is the purpose of a bank? The purpose of a bank is just for helping people to do some monetary transactions. Okay, not only for saving money, it's going to help you to do monetary or currency transactions. Okay, so this is the purpose of the bank. But if you go inside the bank, so you are going to be that the bank is divided in different sections, and all the sections are with the purpose for helping people with your financial stuff. Okay. So here you have, I don't know how to write in English, asesores. Here you have the cajeros, and here you have SOR ATM. Okay. So if you notice, the complete bank in this case is divided in three small processes. The accessories is going to help you to open bank accounts or for getting some. How, I forgot how to say this. To obtain some préstamos, créditos, and in the cajeros you will be able to deposit money, withdraw money, paying services, paying credits, and in the ATM you're going to possibly do the same and more things. Okay, so you are seeing that the big system, that is the bank, is divided in this case in three subsystems. Okay, and those subsystems could be divided in another subsystems that is called further subsystems. Let me explain you with the slides. Okay, here. The main system, the complete system that performs various tasks. Subsystem, different functional areas of the computer, each with a specific role. And further subsystem, each subsystem is divided into even small parts, each handling a specific task. Okay? Why is this important? It's going to give us efficiency. You are going to have something that is called modularity. To explain this, let's suppose that you go to the bank, and in the bank you find just one person, and that person is in charge of everything. So that is not going to be efficient. That is not modularity, because it's just one person doing everything. It's not going to be scalability, because how are you going to improve if you work alone? So if you divide your processes, you are going to have the possibility to upgrade, update, or to improve any service. That means that the complete system is going to be improved. Is going to improve, sorry. Okay. And obviously simplifies the design and troubleshooting. What it is that it's going to be easier to debug and maintain. Okay. Another one here. Now, understanding problem decomposition. So here, if you notice, I am talking about the stage number one. We are in the slide number 7 about the analysis. And now we are going to talk about the decomposition. So that means that we are going to break down a huge problem into a small problems. Okay, so let's get back here. Aquí, here, let me delete this part about the bank because I don't need it. I don't need it. I don't need it. So here we are going to continue to talk about the even software to calculate if a number is even or not. Is not is. Okay. And I told you that we are going to divide this one into sub programs. You are going to decompose this software into small softwares. In the first one, we are going to calculate the remainder. Calculate remainder. Ah! Calculate the remainder. And in this one, we are going to take the decision. if the number is or not an even number. Okay? Okie dokie. So let's continue. For doing this, which are the components? So to calculate the remainder, we are going to, we need inputs. For example, let's suppose that we are going to calculate if the number 3 is an even number. Now we need to process. What is the process? That we are going to divide the number by 2. That means that here we are going to have this one. This is our remainder. That is the process. Then we are going to give the output. But for giving the output, we are going to decide if 1 makes 3 an even or an odd number. How can we do that? So with a just single question. If reminder, as reminder is equals to 1, then we are going to display the number is even, else display the number is odd number. So in this way, we are showing the output. Okay. Now we need to know if the information as output is needed to be stored or not. I'm going to give you another example. Let's suppose once again that we are in our ATM. In the ATM, we need some inputs. So we need the number of the card that you are going to use to withdraw money. You need the PIN of your card. And obviously, you need the amount that you are going to withdraw. Okay? Then the information is going to be processed or processed. Okay? So the system is going to verify if the PIN that you wrote is the correct one for your card number. Then the system is going to verify if you have in your balance enough money for your withdrawal. What that means? Let's suppose that you are going to withdraw 208,000 pesos, and in the system, in your bank account, you have only 100,000 pesos. So you don't have enough money to withdraw this one. So you are going to receive an output message that says that not enough money. Okay, now let's suppose that you are going to withdraw just 50,000 pesos. It's the same process. You are going to put your number card, your PIN card, and the amount. The amount now is 50,000 pesos. So the system is going to verify the amount that you have in the moment that you are trying to withdraw it. So you have 100,000 pesos. That means that you are able to withdraw 50,000 pesos. Now, this information needs to be updated. So, sorry, 5,000, 50,000. Okay. So that means that your new account balance is going to be 50,000 pesos. So this is your new amount in your bank account. So that means that this information is going to be updated and stored for future transactions. Okay, so I hope you are understanding this. Okay, next one here. Okay, this is another explanation, but I already explained. Okay, now why is problem decomposition important? Because it's going to be easier to solve. Is if you have any trouble here, it's easier for you for debugging and correct the problem. The coding of this part, having small parts to code, are going to be easier, is going to be efficient, and possibly some parts of the solution that you are doing here could be used in another programs. Okay, next one. Designing and construction to a solution to a problem. That means that now we are going to go to our second stage, that is designing or design, is planning the solution using diagrams and pseudocode. Okay, so let's come down here. Designing and constructing a solution to a problem. So that means that you are going to start designing a structure diagrams, that is a visual representation of how a problem is broken into subtasks, flowcharts, and pseudocode. Okay, so what is the structure diagram? Okay, so let's try doing this here. Let's talk about the even software that we are going to create to know if a number is even or not an even number. So the first part, obviously, is that you are going to ask for the number. Ask for numbers. So that means that this is an input. Okay, this is one part of the program. With the information given here, you are going to calculate the remainder. Okay, now with the remainder, you are going to determine here if the remainder is equals to 0. And with this information, you are going to give, or you are going to, yes, you are going to give, that could be the output, yes or not. If the number is yes, an even number, or an odd number. Okay, so this could be the structure diagram, that is a top-down approach that shows how a system is divided into subsystems. Okay, okie dokie. Let's continue. Now, when you have this, you are going to create a flowchart, that is a graphical representation of an algorithm using symbols. If you notice here, this flowchart represents the calculation of if a number is even or not. Okay. Next one is pseudocode. That is an structured human readable way to write an algorithm before coding. If you notice here, is a language that is going to be readable, so any human is going to understand. When you say display, is because you are showing something. When you say read, is that is an input. Okay, so that means that here we have messages and inputs. Okay, if you notice here we have conditionals. Okay, and if you notice here, this is the pseudocode of an ATM system, the way that you are going to withdraw some money from your bank account. Okay, now explain the purpose of a given algorithm. Okay, okie dokie. So that means that now we are going to start talking coding. This one, coding, writing the actual program. So for writing an algorithm, obviously you need to understand the purpose of the algorithm. So you are not going to start writing something that you don't understand what you are going to write for or the use of that. Okay, so you need the purpose and you need to understand the process involved the algorithm. So what steps are taken to reach the solution. Okay, so the purpose of an algorithm refers to what is it is designed to do. Okay, so let's continue here. If we are talking about uh, if a number is even or not, you need to, okay, what do we need? Obviously, we need some inputs that are the numbers that we are going to calculate if they are even or not. Okay, so what are we going to do next? We receive the numbers. Okay, we are going to calculate the remainder. And what is next? Okay, we're going to determine if the remainder is zero, then do something else, do another thing. Okay, and here we are going to use the output that means the result of what we are doing. So let's do it here. So let me try to put this here and now. So we are going to start. Begin. Okay, so display. Type a number. Read number. Or obviously you can use input. Okay, so here we are showing a message and here we are asking to the user to use the keyword to type any number. Okay, now what is next? We are going to do the calculation of the remainder. So I'm going to use remainder is going to be equals to the number mod 2. What is this? We are dividing the number by 2, but with the word mod, we are calculating the remainder. Okay? Then we are going to use if remainder equals to 0, then here I'm going to display the number is an even number. Else, I could write the same here, but saying that is not an even number, then we're going to use and if and end here. Okay. So to writing an algorithm, you need to understand the purpose of the algorithms and the steps that you need to follow to build the algorithm. Okay. Okie dokie. Um, Describe the process involved in the algorithm. Yeah, I already did it. Okay, you are going to receive the input, you are going to perform the calculations, you are going to make decisions, and you are going to produce the output. Okay, so we already did it here, everything. This is the example. So here you have it, the same that I did here. Okay. Now, understanding methods of solution. Okay. So this, what I'm going to start explaining you, that depends of the purpose of the algorithm that you want to build. I'm going to start showing you this one first. Okay. If you have an algorithm or you received, okay, I need that you build a software in which you need to find in a list a specific number. This is the best method that you can use to do it. This is a linear search. What that means? I want to explain you this in this way. I'm going to try to do it faster. Yes. Let's suppose that here we have the number 4, the number 5, the number 8, and the number 1. And someone asks you to find if in this list you have the number 1. So what are you going to do? Following this algorithm, you are going to compare this number with every single number in the list and compare that number with those numbers to find the number 1. So the questions could say, is the number is 1. So always we need to start at the beginning of the list, and this is the beginning of the list. So we are going to verify if is 1 equals to 4? No. Then we are going to move to the second place. Is 1 equals to 5? No. Then we are going to move to the next one. Is 1 equals to 8? No. So we are going to move to the next one. Is 1 equals to 1? Yes. So we found the number. This is linear search. This one, bubble sort, método de ordenamiento en burbuja. What that means? That we are going to take these numbers, the same. I'm going to use them 4, 5, 8, and 1, and we are going to sort them, ordenar, okay? And we are going to use these algorithms. So it says that obviously we need to start with this number. And we are going to compare this number with the other numbers. Then we are going to move, not with this number, we are going to start in this position. So remember, this is the position number 1, 2, 3, 4. In pseudocódigo, it doesn't matter here, we can start in 0. When you are programming, you need to be careful that some programs starts with 0. Okay, so we're going to start in the position number 1, then, and we're going to compare them. Then we're going to go to the position number 2, then position number 3, then position number 4. So let's do, or let's follow this algorithm. Okay, so let me do this. Okay, okie dokie. So we are going to start in the position number 1. So in the position number 1, we have the number 4. Okay, so the question is this position, I'm going to put it like this, is this position, the number that is in this position, greater than the number that is in this position? If the answer is yes, we are going to swap them. But in this case, the answer is not true. So now we are going to continue in the first position, and now we are going to compare this first position with this position. So is this number greater than that number? No. So we don't do anything and we continue. Ready? So this one. Is this number greater than that number? Yes. So we are going to swap them. So that means that now the list is going to be 1, 5, 8, 4. And we already finished the first position. Now we are going to start in the second position and we are going to do the same. Now, is this position, this one, greater than this position? No. Is this position greater than this position? Yes. So we are going to swap them. So now this is going to be our new list. 1, 5, 8, 1, 4, 8, 5. And we already finished the second position. Now we go to the third position and is going to ask, is this position greater than this one? Yes. So we are going to swap them. And there we have the information sort. Okay. Just following the algorithm that you have on the left part of the screen. Okay. Next, counting. Counting is, you already know what counting is and the uses of counting. Okay. So, in this algorithm that you have on the red part, you are counting how many times a values appears in a what? In a list of value in this way. Okay, so let's do it because I need you to understand this. Let's suppose that here we have the same values. Well, 1, 4, 5, 4 once again. Okay, so starting asking, okay, there is a variable that is called count, and starts in 0. Okay, so input, that means that let's suppose that we are going to look for the number 4. Okay, so from if that start in 1 to the length of the list. So here we start in 1 and the length of the list is 4. 1, 2, 3, 4. So we are going to move in this list. Okay, so we start in 1 and we finish in 4. Why? Because here you have the positions, okay, or their size, or the size of the list. Okay, so if the list in the position number 1, this one, but obviously this value, the position number 1, we have the number 1. Is the number 1 equals to this number that is the one that we are going to look for? No. So nothing happens. So we are going to start to move now here to the position number 2. And the question is the number in the position number 2, that is 4, is equals to the number that we are looking for, that is 4? Yes, those numbers are equals. So that means that count is going to be equals to count plus 1. So count starts in 0. So count now is equals to 1. Why? Because we found 4 there. Now we are going to move to the position number 3. In the position number 3, we have the number 5. Is 5 equals to 4? No, nothing happens. Now we move to the end of the list. At the end of the list, we have the number 4. Is 4 equals to 4? Yes. So that means that the software is going to execute this again. So that means that now count is equals to 2. That means that the number 4 is twice in the list. Okay? Okie dokie. Let's continue here. In this one, this is a little bit longer, but I am going to try this. I am going to use the same list that I have here. So let me delete. In this one, we use the process that is called maximum, minimum, and average. Okay? What that means that we are going to find the maximum number in this list, the minimum number in this list, and the average of this list. So as always, we must start at the beginning of the list. The beginning of the list, I'm going to use the green color. So we are going to start here. But if you notice at the beginning of the algorithm says that the max is going to be the first item on the list. In my case is 1. And the minimum value is going to be the first item in the list, that in this case is 1. Okay. And total starts in 0. Okay. Now let's continue. Now we are in the 4. Is the item in the first position greater than max? So max is 1. And the number in the first position, in this case, is 1. Is 1 greater than 1? No, nothing happens. Now, it's asking if the number in the mean part is less than the number that we have in the list. No, so nothing happens. Okay? And now, total is equal to total plus the item in the list. So totals now is equals to 1. Why? Because totals starts in 0. Then the software, wait a moment, please. I'm going to reject. Sorry, because I am recording a video. Sorry. So now total is now 1. Why? Because the initial the first value of total is 0, and the software is asking me to do something like this. Total is equals to total plus the item that we have in the list in this position. Remember that we are in the position number 1 in this moment, and the item that we have there is 1. So that means that now total is equals to 1. Okay, now we move to the second item on the list, that is number 4. Now, the algorithm asks, is the item in the list in the position number 2, that is in this moment is 4, is greater than max? So 4, this 4 is greater than max. Max is equals to 1. Yes, so that means now that max is going to have the value of 4. The second question is, if is the item in the list position number 2, 4, is less than mean? No, because mean is 1. So remains in the same value. Okay. Then it says total is equals to total plus the item in the list. So that means that we have 1 plus 4. Now total is equals to 5. Why? Because the previous value was 1 and 1 plus 4 is 5. Okay. Now we're going to move to the third place on the list. Now, the third number on the list is the number 5. Now, 5 is greater to 4. Why? Because it's asking if the number in the list is greater than the number that we have in max. Yes, that's true. So that now max is equals to 5. Now, 5 is less than 1? No. Why? Because the algorithm is asking if the value in this moment in the list is less than the value that we have in the variable min. And that variable, its value is 1. So 5 is not less than 1. So nothing happens. Now, total is going to be equals to 10. Why? Because the previous value was 5. 5 plus 5, remember that we are executing now this line, is 10. Now we move to the next item in the list and we continue the process. Is 4 greater than 5? Why? Because we are asking if this number is greater than max. No. Is 4 less than 1? Why? Because we are asking if this value is less than this value, and no. Now we are going to execute again this. So that means that total at the end is going to be equals to 14, and the average is 14 divided by 4. So what that means, what is the result? 3 point something. This is the average. Okay, so this is another method of solutions, finding the maximum, the minimum, and the average in a list. Okay, now let's continue here. Now, look at here. We are in the slide number 33, and I am going to get back to the slide number 6, because we already saw analysis, we already saw designing, and we already saw coding. Now we are going to talk about testing. So testing is checking that the programs works correctly. Okay, so I get back to the slide number 33. So here we need to know two things: validation and verification. So there is something that, including me, this is something that is confused. Okay, so let's talk about here. So validation is just the process of ensuring that the input data is sensible, reasonable, and acceptable before it is processed. Okay, what that means? If you're going to and no, here. Let's suppose that you are going to create a software in which you are going to um okay, let's suppose that you are going to have a form in which you are going to ask this information: names, age, birthday, and let's suppose that here you are going to create a user. So here we are going to use a nickname and a password. Okay, what is validation? That here in names, obviously you are going to put names. For example, it's possible for have a name, for example, Nicolas Ocho. Who say not? That's okay. Age, M. This is not okay. So that means that you are going to validate that the information that is going to be input are acceptable information. Okay, let's suppose that here in birthday you have something that is called, remember that we talk about format date. Here in Colombia we use day, month, year, Okay. And let's suppose that the software calculates that you are going to be able for sync up to this application if you are 21 to 46 years old. So when you put your birthday, the system is going to calculate if you are in this range, for example. There is another one that you are going to validate that the information given is in a range, for example. Now, here, a nickname, another way that you are going to validate something. Let's suppose that you are going to create a nickname that must have 8 characters at least. So you are not going to be able for putting or creating a nickname like this. Nico 9. 1, 2, 3, 4, 5. No, because need to be from 8 on. Okay. The password, and let's suppose that here we are going to use another once again password, and here email. And in this one, you are going to validate that the email has the at. Okay. You cannot write, for example, david.reyes.lsb.edu.com. No, you need to put david.reyes arroba. Okay, that is validation. Okay. This is validation that you are going to be sure that the data is reasonable and acceptable. Okay. So here you have some examples. Ra- Range check. The one that I told you here that your age must be between 21 years old and 46 years old. Not younger, not older. Okay. And type check. Okay. That you are going to be sure that here you put for any number, for example, 22 and not a letter. Okay. Presence check. That means that you are going to be sure that, for example, you put something here. These fields cannot be empty. No, that is presence check. Format check. This one that I told you that, for example, your birthday must be in this format, día, mes, año, and your email must have the arroba, the at. Okay, that is format check. And check digit. Let's suppose that here the system is asking for your credit card number, and the credit card numbers has something that is called check digit. Do you remember this in transmission, data transmission? What is the check digit? That there is a digit that is going to be used for checking all the information. In this case, the credit card number. I'm going to give you an example. Let's suppose that I'm going to write 1, 2, 3, 4, 5. Okay. That means that if I add these numbers, the result is going to be 15. Yes. And let's suppose that my credit card number is this one. 1, 2, 3, 4, 5, line 15. That means that this is my check digit. And this is the adding of those. Okay. But this is used only for financial things or for example, credit cards, debit cards, from libraries for the ISBN code that all the books has. Okay. Okie dokie. Okie dokie. Let's continue. This is just an algorithm for asking or verifying, validating range age. This one is for the length checking, the one that I told you for the password or the nickname. And this is that you are validating if you are using numbers between text. This is that you are putting information in a field, the one that I told you that those fields, for example, cannot be empty. So you need to verify that someone puts some information there and those fields are not empty. And the other one is the format check. Like for example, in this one, we are verifying if your email has an at, okay? And this is the check digit. There are many ways for checking digits that depends of the method that you use for your check digits, okay? That is validation. So remember, validation is just to be sure that the data is reasonable and acceptable. Okay. Now, verifying or verification is the process of ensuring that the data that you put in your form matches with the original data to prevent input errors. Okay. What that means. For example, here, the best is using here. For example, when you are using your or you are going to create your nickname, obviously for validation, you are going to be sure, sorry, you are going to be sure, okay, the sequence is going to be sure that you put 8 characters. So let's suppose here, 1, 2, 3, 4, 5, 6, 7, 8. Let's suppose that this is our username. Okay. Now, validation is your process. Your Then you are going to verify if this one is the data that you really want to put there. Okay. So, for example, let's suppose that in the nickname, if you put this one in which you put this asterisk, possibly possibly you are going to have something that is called um input error. Why? Because for the nickname, why you put an asterisk in your username? So let's suppose that here we're going to change this, and now including this one. Let's suppose here Nicholas 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. Okay, that is going to be my username, Nicholas95. So I'm going to be sure that I wrote the things that I'm supposed to wrote. That is visual check. Visual check. That is what I told you, that this is your part, that you are going to verify if the information that you are writing is the correct one. Now, the other verification is called double check, double entry. This is another example. Let's suppose that you are going to create your user in a software and you are using obviously your nickname that we already put it here, and we verify that this nickname matches with the information that the software asks us to put. Okay. And the double entry is that, for example, here you are going to put your password and you are going to put the password here too. The software is the one that is going to verify if the password that you put here is the same that you put here. Okay. So we have visual check that you as user do, and the other one that is double entry, that is the software does. The software is the one that is going to verify, for example, in this exercise that the password you put it correctly. Okay? Okie dokie. So, types of verification checks: visual check and double entry. Okay? Use a visual check example, checking a receipt manually. Users visually inspect data to ensure it is correct. Real life example, a bank employee checks that the account number on a form matches with the customer's ID. Double check entry, I already explained you. So now, suggesting and applying suitable test data. This is when you are going to start testing if something works in your algorithm. Okay, so testing ensures that an algorithm or programs work as expected by checking its behavior with different types of data. If a program is not tested properly, it may produce incorrect results or crashes when used in real world situations. So you have normal data. Let's read the example. The example is that you are going to validate age between 18 and 65. Normal data, for example, you put 25, is inside the range. Abnormal data, instead putting a number, you put letters. Extreme data. Extreme data means that you are going to use the limits of the range. In this case, the range is 18 and 65, and you use them. You put 18 or 65. That is the extreme data. And boundary data is when you put something outside the range, in this case. 18 to 65, you put 17. That value must be rejected. If you put 18, that value must be accepted. Okay. So consider this pseudocode for checking a valid age input between 18 and 65. Okie dokie. So we test that algorithm using these values. So if I put 30, valid. 20 in letters, invalid. 18, valid. 65, valid. 17, invalid. So you must send a message that says that value is not between the range that I gave you. Remember, the range is 18 to 65 or 64, for example. No, yes, 65. And I put 66 is outside the range. Okay. Now, the trace table is something that you now understand what to do, is that you are going to start taking your, let me do it in this way once again. So you have the algorithm and you need to identify in your algorithm how many variables are you using. So for this example, I am using a variable that is called x. Is the only one. So here I'm going to use output. Output. So I start following the algorithm step by step. So x starts in 3. So here I'm going to put 3. Then while x greater than 0, do. So output x. X is equals to 3. Now, x is equals to x minus 1. So that means that now x is 2. So the output is going to be 2. Now x is going to be 1. So the output is 1. Now x is going to be equals to 0, so nothing happens. So this is the tracing table of this algorithm. Next one is what I show you. So identifying and correcting errors in algorithms. So here you need to understand this, guys. There are 3 kinds of errors in an algorithm. The first one is about syntaxes. Syntax. Now let me try to write in a little bit better. So here I'm going to write, sorry, syntax. The other one is going to be logical, and the other one is that the programs has start running. I don't run time error. That means that when you, let's suppose you don't have any syntax error, you don't have any logical error, but you start running the software and the software crashes. That is runtime error. Okay. So let's see every single kind of errors here. So logical. No, sorry, syntax. Okay. In syntax, for example, let's suppose that you have this algorithm. So I'm going to begin a count equals to 0. Now from e that starts in 1 to 10, do. And here I'm going to write count equals to count class. Next e end. So let's suppose that this algorithm, the purpose of this algorithm is to show you accounting. So here we have one syntax error. Why? Here, here we are going to have an error. Why? Because the algorithm was not writing properly. Here we are missing something. E, for example. Now the line is completed. So we have solved the syntax error. But now we have a logical error. Why logical error? Because I told you, these algorithms need to show accounting. It's not showing nothing. So that means that here to correct this error, I'm going to do this. Display count. Now the counting it's been shown. And in this way, we correct the logical error. Okay, so I hope this is clear for you. So this is what I was showing you, the syntax, the logic, and runtimes error. This one is for logical error. Okay, so the purpose of these algorithms, so I'm going to read it like this. The purpose of these algorithms is just for showing the sum from the numbers 1 to 5. Okay, but it's a logical error. Why? Because it's going to show you, let me show you, I'm going to write it here. It's going to show you the adding of 1 plus 2 plus 4 plus 1 plus 2 plus 3 plus 4, no more. Why? Because here you are using this conditional, x less than 5. So that means that the algorithms excludes the number 5 from the sum. So you need to change it to correct it to this one. You are going to put that the x is less and equals to 5. In this way, the problem is solved right now. Okay? This is logical error. This is another one error in which possibly, apparently, nothing is going to happen. Why? Because if you notice here, this algorithm is going to show the numbers from 1 to 5, but has an error. What is the error? The condition. The condition says is you are going to show the numbers while n that starts in 1 is greater than 5. So always 1 is less than 5, so never is going to be true. So to correcting this, you need to change it to this one. While n is less or equals to 5. Give me a minute, please. Okie dokie. In this way, we correct the algorithm and now it's going to work properly. Okay? So guys, this is all for this video, for this presentation. So I hope that you can understand a little bit more with this, but please bring me questions to the class. Okay? And the video is just 5 minutes shorter than the previous one. But okay, thank you for being here. So let you see in class. Bye.